Okay, so section 9.3 is about what? Okay, let's not get complicated. Adding and subtracting, right? Which is really not super necessary since that's kind of adding, right? And then they say something about rational expressions, right? Which we should probably remember are just scary fractions.
Very scary.
Okay, but there's nothing new in section 9.3. There's not a new in here at all. It's just scarier. So remember, right, that we had ways for adding and subtracting fractions before, right? So if we had 3/7 minus 2/7, what do you do?
Oh, I'm sorry. 1 cent.
How are you getting that?
Yeah, and it's the same.
You're saying, okay, they've got the same bottom, right? So the units I'm talking about are sevenths. So I've got 3 minus 2 of them, right? Which means that all told here there's 1/7, right? The step I want to highlight is not this one, right? But this one. So this is the step I want you to pay attention to, right? Which is that when the bottoms are the same, you can just do the addition or subtraction with the tops, right? Okay? Maybe let's have a scary example for this. Yeah.
That's the one. Sorry.
Okay, so let's have a scary example for this. Let's take x minus a over a plus b times x plus 4. And we'll subtract x plus b over a plus b times x minus 4. Okay, so no panic, right? It's a scary fraction, but I treat it just like I do a regular fraction. So the first things first, okay, I'm subtracting, right? That means I need to make sure the bottoms are the same. So, are the bottoms the same on this?
No.
Oh, whoops, sorry. Are the bottoms the same on this?
Yes.
Yes. Sorry, my bad, typo. Okay, so the bottoms are the same, right? Or at least they are now, if I had read the problem out of the book, right? Okay, so let's see. How do I subtract when the bottoms are the same? Sideways. Okay. I leave the bottom alone, right? Because I'm not doing anything with it. And then on the top, I had x minus a of whatevers, right? And then somebody came along and took away x plus b of them, right? You guys see that? So I started with x minus a of them, and then someone came and took x plus b of them. You see this? So is that the whole answer? I don't know. Can you simplify it?
Yes.
Yeah, a little bit. So let's see. Let's simplify a little bit. What do we get on the bottom? Okay, let's see. So there's an x minus an a, right? Are these parentheses necessary?
No.
Why not?
Because they're not multiplying.
Because everything has the same order here, right? This is all this junk is happening at the addition level. The only thing that's not happening at that level is this minus, right? That's a multiplication level, so I have to do that first, right? So let's see, I've got an x minus a, and then I need to distribute this through. So what am I left with there?
Negative b, negative x.
minus b.
Minus x minus b. And what happened to the bottom?
That stays the same.
That stays the same because really here all I'm doing is simplifying the top, right? Okay, so the bottom is a plus b times x plus 1. Okay, now what?
Now get rid of your x's.
Why?
Because we cancel it. X minus x is no x.
You guys see that? This is not quite the same cancel as we did in 9.2, right?
This is just
I'm not
this is
saying-
canceling, this is subtracting.
Yeah, I'm not saying this over this is 1. I'm saying this minus this is 0. You guys see that? So here we're saying, all right, x and minus x, if we combine like terms, gives me 0 x's. So what am I left with? Maybe I would do this.
Negative
Negative a, what would?
minus.
Minus b.
So it's not a negative and negative. Oh, it's because we're adding.
Yeah, it's because I'm adding, right? So these guys canceled because x minus x was 0. And then here I have a minus a plus a minus b. All right, what about the bottom there?
Stays the same.
Bottom stays the same. So I've got a plus b times x plus 4. Can I do any more simplification?
You can boil it out if you want.
Don't FOIL it out.
Take out negative one.
I can take out a negative 1 on the top. What does that lead to? Okay, see that? If we kind of undistribute, right, factor a negative sign out of the top, we're left with a plus b.
Wait, why did you have to multiply the minus one again?
I'm factoring the minus 1. Right? I'm saying both these terms have a minus. That means if I pull a minus 1 out, I'll get an a plus b left over, and that'll match this bottom term. You guys see that? So now I have a 1z, right? This thing over that thing is 1. And I'm not doing a false cancel, right? There's no addition on the top. So cancel those, and we're left with negative 1 over x plus 4. You guys see this? Yeah.
When you went from the first step to the second one, I didn't really understand what you did at the bottom.
Okay, so this was me saying, all right, I have x minus a of whatever these guys are, right? In the same way here I had 3/7, right?
Oh, never mind, I thought you did.
So here I'm saying I have x minus a of these units, and x minus b of these units went missing. So now I have,
You're using the same bottom.
yeah, these have the same bottom, so I didn't need to go out and find anything. You guys okay with this? All right, what's the next logical harder step? Yeah, when the bottoms don't match, right? So you guys got a number example for when the bottoms don't match?
Number 35.
No, make one up.
Okay, oh,
She made it. You already.
Make up a number example for when the bottoms don't match.
1/3 minus 1/4.
Sure. A third minus a fourth. What do?
LC.
You need to find a common bottom, right? Okay, so what's the common bottom between 3 and 4? 12? Okay, so what do? Say, all right, this is a third minus a quarter, and now I need to multiply top and bottom by some stuff, right? What treatment does the third get? That gets a multiplication by 1, that's a 4 over 4, right? You guys all should hopefully be pretty used to this. All right, how about the right-hand term? What treatment does the 1/4 get? What do I put here? 3 and 3. Okay, that's also multiplication by 1, right? Resist the urge to cancel these. Why shouldn't you cancel these?
Because they're adding. In other words, when it's
We're not
subtraction
multiplying,
and
it's
addition.
Oh no, you can go ahead and cancel them, but you're trying to do something, right?
Well, we wanna have a bigger number so that we have a common factor.
You guys see that? I want to get a common bottom. If I put these in and then cancel them, what happens?
We get the same way.
Nada, right? I'm back to where I started. Don't fall into that little loop. I know it seems really dumb right here to fall into that loop, but in the rational expressions, I guarantee I will watch one of you fall into that little loop. It happens. I do have perfect faith. One of you will do that. All right, so when I multiply, let's see. What do I get out of the first term? 4 12s. And I'm subtracting how many 12s? 3 12s. So I'm left with 4 minus 3 12s, right? So this is the step that I'm hoping to highlight, right? This one where I went from kind of different bottoms to this new one where I had, I do both of these. This new one where I had common bottoms, right? And then I could do the thing I just learned, or I just remembered, right? Cool? You want to try one with scary fractions?
Yeah, why on the book? I mean, that's huge.
I don't know, let's do an easy one first, and then we'll do one of the huge ones out of the book. Okay, so here's one. Are the bottoms the same?
No.
No? Okay. So what do I need?
X plus 2, 1, X minus 1.
Basically this. I need a common bottom, right? So what's the common bottom here? What should I think? Alright, so I want to think common bottom is x plus 2 times x minus 1. Right? Keep in mind, you don't always have to multiply all the bottoms together. Sometimes you can get away with just parts of them. Like if this was 6 and 4, the common bottom would still be 12, right? We'll have a little bit of practice with that. But right now, I've got this guy as my common bottom. So what does the x plus 2 guy need? I've got 3 x plus 2's, right? What do I need to multiply by that one?
X minus 1, X minus 1.
That one needs an x minus 1 on the bottom. So I'll have to multiply by x minus 1 on the top too. Now I'm going to subtract, and we've got 4 over x minus 1. And what do I need to multiply this by?
X plus 2.
X plus 2, right? That's what it needs on the bottom. What does it need on the top?
Same thing.
Has to have the same thing, right? Now this is the spot where some of you will cancel, right? Careful, don't do that. You wanted the common bottom, right? All right, let's see. What else have I forgotten notationally here? Do you guys see anything I could improve? Oh, yeah. Really, I should probably have some parentheses around these. The bottoms I already had, so I don't screw them up. Cool. All right. In the next step, what do I do? Okay. Resist the urge to foil. Don't foil the bottoms. Probably want to leave the bottoms the way they are. But what do I have on the bottom? How about that? Oh yeah, there's an x minus 1 times x plus 2, right? That was the point of this. I got the common bottom, so now I can just do my usual on the top, right? So what's the usual look like on the top?
minus 3.
Minus 3.
Okay, so you get to pick. You can either leave the parentheses or you can distribute out. I don't care what you do. I'm going to leave the parentheses for just a tick. Okay, so I got to here.
Now.
The reason I'm leaving the parentheses is that I personally am too dumb to get this minus sign in the right spots if I don't. If you can get it in the right spots reliably, go for it. But I personally need it. I need the parentheses to remember that this was really a minus 4 that I was distributing. Otherwise, I lose it on the second term. All right, so now I've got over x minus 1 times x plus 2, what? What do I get on the top here?
3x minus
3x minus 3, good distributing. And then
4x.
minus 4x minus 8. Cool. Now what do I do?
Like terms, something.
Combine some like terms, right? So let's see. Again, this is all over the bottom, right? I'm not changing that. I'm just simplifying the top. And what do I get when I simplify the top?
Negative x minus 11.
Negative x.
See, I had 3 x's. Somebody took 4 away. That leaves me with a det of x.
Minus 11.
Minus.
And then there's negative 3 and negative 8 gives me negative 11. Okay, now what do I check?
Now you want to do
Negative.
your negative 1.
I could take a negative 1 out. I just want to check whether I can cancel, right? If I take a negative 1 out, so I take a negative 1 out, what am I left with on the top?
X plus 11.
X plus 11. And on the bottom, I've got a x minus 1 times a x plus 2. Can I work with that? Nah. That one's done. I can't cancel anymore. Yeah.
How did you get negative x?
I had 3 x's and then minus 4 of them.
Then you did negative 3 and negative
And then I did negative 3 and negative 8. Yeah. Really what I'm thinking there is I'm kind of thinking, okay, there's 3 x's minus 4 x's minus 3 minus 8, right? This is the same thing. And then I'm saying, okay, this is x times 3 minus 4, right? If I factor an x out of those. And this is x times negative 1.
Yeah, I see.
Same thing with these guys. What's up?
Okay, when I'm looking back and I see the 3, x minus 1, and 4, x plus 2, those are my same factors down at the bottom, so how come I can't cancel right there?
False cancel,
Okay.
right?
Because the 4 is connected and the 3 is connected?
Because
Is that why?
these guys are being subtracted, right? Not multiplied. If this was a multiplication symbol here, sure, cancel away.
Okay.
But because this is subtraction, this is a false cancel.
Okay.
Yeah.
If it doesn't make a difference at the end, is it okay if we don't factor at the negative 1, or do you still want us to?
Sure. Yeah, so I would have left it here because I personally see, okay, I could pull a negative 1, but then I'm left with an x plus 11. I don't have that on the bottom.
Okay.
Cool?
Yeah.
So yeah, either place, both of those are right. I don't care which one you give me. Other questions? Okay.